Hi, today we are looking at section 1.4, in which we're still looking at compound interest, but we're going to be solving for different values than we did in the previous section. In the last section, we only really solved for our amount or our time for it to double. Today, we'll be looking at solving for our present value, also known as principal, or interest rate, or our term. So present value is a value being invested, also known as our principal. So rearranging our formula for present value, if we've got A is equal to P times 1 plus I over N to the power of NT, it is actually just one step to get our principal on its own, because our principal is technically being multiplied by everything here. So we'll do the opposite operation and divide both sides by 1 plus I over N to the power of NT. And because we divide this side by it, we also have to divide this side by it. So that's 1 plus I over N to the NT. So A over 1 plus I over N to the NT is equal to our principal. Okay, so for example, Mark is 15 and wants to spend $5,000 on a vehicle when he is 18. How much does he want to invest now if the rate he gets is 7% compounded annually? We want to know what the ratio is to future value to present value, and how would A and B change if the rate was dropped to 5% and it was compounded quarterly instead? Okay, so for this first one, we know our amount we want at the end is 5,000. We're solving for a principal. We're given our interest rate, which is sometimes also written as I, is 7%, which is 0.07. And our time is going to be 3 years, because he's 15 now and wants it when he's 18. So we'll start part A with our formula of A is equal to P times 1 plus I over N to the power of NT. We will gradually rearrange this, so I would divide both sides by 1 plus I over N to the NT. Both will cancel out, so we have our principal on its own. So now we'll substitute our values in. So we've got 5,000 divided by 1 plus 0.07 over 1, because this one was annual. So technically our N was 1 to the power of 1 times 3. And that's our principal. So we'll go through and simplify this a bit. So we have 5,000 divided by 1.07 to the power of 3 is equal to our principal. So that's 5,000 divided by 1.07 to the power of 3 is 1.225043. So 5,000 divided by that means that right now he would have to invest $4,081.49. Part B is, what is the ratio of future value to present value? So ratios are typically represented by fractions. So if it's saying a ratio of future value to present value, the first thing we have would go in our numerator. So our future values are A value over our present value, which is P. So our ratio could be represented as a fraction, which would be our 5,000, should be our future value over our present value of $4,081.49. And we can also represent it as a decimal by doing this division, and that gives us 1.23. Okay, part C is essentially the same thing, except for we are changing our R, or our interest rate, which will be 5%, which is 0.05, and our N is quarterly, so it's going to be 4. So we'll start out with A is equal to P times 1 plus I over N to the NT. Rearrange this, get P on its own, so divide by 1 plus I over N to the NT. Those will cancel out, so we have our A, which is $5,000, over 1 plus 0.05 divided by 4 to the power of 4 times 3 is equal to our principal. So we have 5,000 over, we'll simplify what's inside our brackets. So that gives us 1.0125 to the power of 4 times 3, so 12 is equal to P. So we've got 5,000 divided by 1.0125 to the power of 12, which is 1.1607, and this just continues on. So I'll keep on my calculator. So I'll go 5,000 divided by it. Now we got 4,307.54. So obviously it looks like if we do the second option, or the interest rate drop to 5%, he would have to invest more money to end up with a $5,000 in 3 years. Now, if we do our ratio A over P, so we've got 5,000 over 4,307.54, and it gives us a ratio of 1.16. So because this ratio is a lower number than this one earns less interest. Okay, next we're going to look at determining an unknown interest rate. So to determine the interest rate, we can rearrange our formula as follows. So we want to get R on its own essentially, so we'll start by dividing both sides by our principal. So we have A over P is equal to 1 plus R over N to the power of NT. Now, our next problem is its exponent. So we need to get rid of exponent on this side. So what we'll do is take the NT root of both sides. So the NT root of A over P is equal to 1 plus R over N. We would then subtract 1 for both sides. So we have the NT root of A over P minus 1, making sure you leave this minus 1 outside of our root, equals R over N. And then to get R on its own, we would multiply both sides of our equation by N. So that would give us N times the NT root of A over P minus 1 is equal to R. Okay, so we'll look at an example of that. You invest 20,000 and want to know what interest rate would make it 50,000 in 10 years if compounded yearly. So we have our principal is 20,000. Our amount we end up with is 50,000. Our N is equal to 1. Our T is equal to 10. Now we're solving for R. So we have A is equal to P times 1 plus R over N to the NT. We'll divide both sides by our principal. So we've got A over P is equal to 1 plus R over N to the NT. So we'll take the NT root of both sides. So it's a NT root of A over P is equal to 1 plus R over N. We'll subtract 1 from both sides. So we've got the NT root of A over P minus 1 equals R over N. Now we'll multiply both sides of our equation by N. So that gives us N times the NT root of A over P minus 1 equals R. Now we'll substitute our values in. So we've got 1 times essentially 1 times 10 as our index, A over P, so 50,000 over 20,000 minus 1 equals R. Now 1 times anything is itself, so we can get rid of that 1 in front. 1 times 10 is 10, so we've got a 10th root of 50,000 over 20,000 minus 1 gives us R. So that's going to give us 1.096 minus 1 equals R. So 0.096 equals R. Now, if that's our interest rate as a decimal, we need to multiply it by 100 if we want as a percentage. So we'd have 9.6%. Now, to solve for term length, we have to use one of the functions on our calculator. So to find the term length, we're going to press the apps button on our calculator, select finance, select TVM solver, enter interest rate in for a percentage, enter the principal for PV. We have to put in as a negative value though, put 0 in for payment, or PMT, which stands for payment, enter a final amount when we've got FV, which stands for future value. We're going to put 1 in for the P/Y and for the C/Y. And then we'll press second and quit, press apps again, finance, and select TVN. So how long until a $10,000 investment equals 80,000 if we compound it 5% annually? So we'll follow those steps. So we are going to press apps, finance, and then TVM solver. When that screen comes up, we're going to put where it says I percentage, we'll put 5 in. For present value, we'll put negative 10,000 in. For PMT, we will put 0 in. For future value, or FV, we put 80,000 in. Payment or P plus Y is 1, C slash Y is equal to 1. We'll then exit that window, open up the program again, and select the TV M underscore N, and that should give us 42.6. So we'll round that up, and that gives us 43 years.